Hello again. This is the third and final part of our three-part interactive tour of one of PGE's distribution substations. Just as in the first two videos, we'll start by highlighting the anchor point, the 115 kV line and monopole. This time around, our 360 camera is towards the rear of the substation, so our anchor point is now quite far in the distance. Also of note, in the two previous videos, our guided tour swiveled to the right, but this time around we'll eventually be swiveling to the left. But let's begin by first focusing on the ground for a minute. You might immediately notice a distinct border between two areas of rock on the ground. The first, lighter colored rocks in the background, furthest from you, consist of insulated rock. Insulated rock is another safety feature of the substation that prevents step and touch potential. The area consists of a 6 to 8 inch depth of this insulated rock all through the substation. The rocks are of a sufficient size so as not to form a solid base. This is because if the rock were a solid base, that base would more likely ground anyone standing on it, which of course is unsafe. Also of note, this rock isn't just any old rock. It's in fact tested to a specific standard. These particular rocks and all the rocks used in PGE substations come from only two quarries in the Pacific Northwest. Now, as you continue to look at the ground, you can quite clearly make out a transition within the rocks from the lighter colored insulated rock in the background to the darker rock in the foreground. If you spin your camera to the left and stop when you have the transformer in the center of your screen, you can clearly make out the difference even more. This darker area of rock that the transformer sits on is for oil containment. This is here to safeguard against the possibility of a catastrophic failure in which all the mineral oil would leak out of the transformer. To mitigate such a failure, this barrier of rock is about 4 or 5 feet deep, lined on all sides, and acts like a pool for the oil to drain. This would prevent the oil from causing any environmental problems in the soil surrounding the station. Lifting our gaze from the ground slightly, the large boxy structure right in front of you is one of the two transformers. Attached to the side of the transformer is the cooling system. The cooling system consists of convection radiators and a series of fans that help cool the unit, preventing overheating. Inside this transformer is where our 115,000 volts gets stepped down to 12,500 volts. This step-down transformer is made from 2 or more coils of insulated wire wound around a core made of iron. When voltage is applied to one coil, frequently called the primary or input, it magnetizes the iron core, which induces a voltage in the other coil, frequently called the secondary or output. The turns ratio of the two sets of windings determine the amount of voltage transformation. You can see the lines clearly going from the circuit switcher or breaker to the transformer. Once again, before entering the transformer, the voltage is 115 kV, and upon leaving, it's just 12.5 kV. Housed inside this box is a nitrogen regulator. The regulator keeps a nitrogen blanket on top of the entire transformer, thus preventing oxidation. This inert gas ensures no moisture can seep into the transformer, which could cause damage to the equipment. Now, if you continue to spin your camera to the left, you will see the two metal-clad structures at the low side that the newly transformed power leads into. Housed in these structures are the relays and controls for all the equipment we previously mentioned. And finally, the power exits the metal-clad structures via underground cables, which connect to distribution feeders. We hope you've enjoyed this guided 360-degree interactive tour. Special thanks to the good folks at Portland General Electric for taking the time to tell us about their substation and answering all of our questions.